In this video we'll be taking a look at NMap, which is an open source network scanner used to discover hosts and services on a computer network by sending packets and analysing the responses. So this is probably one of the most commonly used and the most important tools on a penetration test, and we'll try to cover some of the main features of NMap in this video. I will say that documentation is really good, so everything that I cover in the video will be covered here, and there'll be a lot more options as well which I won't go through, but we'll try to cover some of the main aspects. Also, there's some good cheat sheets out there, so you can go to hyon.coffee and get the NMap cheat sheet here. So if you're working on a vulnerable machine or doing a penetration test, you might just want to go and quickly grab some commonly used commands or take a look at some different options here. So that's also worth checking out. You can also bring up a list of options just by entering NMap in on the terminal. Let me minimize this so you can see this a little better. So if you just type NMap, this will actually give you like a summary of the different options. So we have target specification, host discovery, scan techniques, and these are essentially what we have here, and it'll just give us the key options, key commands, but it won't cover everything that's in the full documentation. I'll also be using Metasploitable 3 in this video. So at the beginning of this series we set up the Metasploitable 3 VMs. So there's a Windows Server 2008 Server VM and a Ubuntu VM, both with vulnerable services running on them. So I'll be using those systems in this instance to demonstrate some of the features of NMap. So before we start digging into the different options in NMap, let's just try and run a scan without any options provided. We'll run nmap against scanme.nmap.org, and a few things are going to happen here. The first thing will be it's going to convert scanme.nmap.org into an IP address using DNS. It's then going to ping the host to determine whether it's up and online. It'll then convert the IP address back into a name using reverse DNS query, and then it'll launch a TCP port scan of the most popular 1000 ports, so not ports 1 to 1000, but the most popular ports that are likely to be online. You can see it's come back with some results now, and then it'll print this out to us. So there's 5 steps that occur whenever we run this basic NMap scan, and you can see that it's returned to tell us that we have 4 ports that are open out of the most popular 1000 ports, and we have 996 filtered ports. So we're going to get some different states here. We might have ports which are open, which shows that the service is open and receiving packets. We might have closed, so it's not open to the public, and we might have filtered or filtered open, filtered close, where essentially it's not able to determine whether the port is open or closed, and in that case there might be some kind of firewall which is causing issues. In this case we specified a single domain as our target, but in the case of testing a network there's a chance we might want to run over a series of IPs. Let's go and have a quick look at the reference here for target specification. And I'll not go through all of this information here, but a couple of things to note. We can specify a range in the following way. So we can provide a domain name like we did there, scanme.nmap.org. We could provide an IP address, so let's say 192.168.0.1. If we wanted to use a range, then we could use CIDR notation and say we want to go over 24, so we're going to loop through 0 to 200 or 1 to 255. Or we could do a similar thing. We can actually say 1 to 255. I believe if we use 0 here, it doesn't actually, NMap by default will still only go for 1 to 254, but I may be mistaken there. We can also, as it shows here, we can provide our IPs as a file. So if we use the -il, and capitalization is required here, so if we say -il, and then we could give in, say, nmap.txt, which would just have a list of IP addresses separated on new lines, and we can use -ir to select random targets. Now it mentions here use this at your own risk, so if you use IR 0, this will just loop through forever, just scanning random targets on the internet, so you might get a knock on the door if that's the case. And we can also exclude, so in the case where we want to specify a whole network but certain IP addresses are out of scope, we're not allowed to scan them, then we might want to exclude, or we can provide a list of excluded domains or IP addresses as a file as well. I think that's everything we need to see about the target specification. The next thing we want to take a look at is host discovery. So whenever we ran the scan against scanme.nmap.org, it took a minute or two to come back, even though we ran a very basic scan and we're only testing the top 1000 TCP ports. So you can imagine if we're scanning all 65k TCP ports, maybe we're doing UDP ports as well, which is really slow, and maybe we have a very large network to scan. It's going to take a long time. So something you might want to do first is actually just make sure that the hosts are online. So we have some different options here. You can see a very basic description. Our SL will list the targets to scan. So we can provide, for example, a domain name, and it will give us the different IP addresses that we want to scan further. We have a ping scan, which will disable the port scans, so it's only going to do a ping sweep basically, just to make sure that the hosts are online, and then based on whichever host you find to be online, you can then run a more detailed scan. And then you have -pn, which will treat all hosts as online, so typically you're not going to want to run this. This will take a very long time. If you're running this against a large network and not all the machines are online on the network, it's still going to run the full scan for every machine. So typically you'll be running one of these two scans for host discovery, most likely a ping sweep, which is what we're going to try now. So just to mention as well, if we go back to our reference guide, there's a lot more information about this. Go to host discovery and you can find some good documentation on each of those options that we went through, as well as a lot of additional options here as well, which I haven't really explored. So we're going to test this out anyway. We want to find out what the IP addresses are of the Metasploitable machines. We know that this machine is on 10.10.10, so presumably we'll be able to do nmap-sn, which will be our ping only scan, and then 10.10.10 points, and we could do our 1/24, or we could do 1 to 255. Either of those should be fine. And this will just go through and just try and find out which of the machines are online. Hopefully it'll come back and tell us that this Ubuntu machine and this Windows Server machine are online. So you can see that's come back. We've got 5 hosts which are online, and now we can go and run some more detailed scans on these hosts to see which ones are our targets and which ones are out of scope. Before we look at the port scanning options then, let's just create an ips.txt file, and I'm going to paste this in. We'll just list the IPs that we're going to want to run a more detailed scan on, because we know we can pass in a file using the -il flag. So let's go back to the terminal and do nmap-il. We'll pass in ips.txt, and let's go and have a look at the port scanning options. So if we go back to our reference guide here, the port scanning basics will just tell you a little bit about the different types of states for the ports, being open, closed, filtered, etc., which I've already kind of covered a bit. And then the port scanning techniques will give us the different types of port scans that we can run. So the TCP SYN scan is the default and most popular scan option. It's quick, it can scan thousands of ports a second on a fast network, and it's relatively unobtrusive and stealthy since it never completes the TCP connections. So these are known as half-open scans, and if this isn't available, the next best thing is the TCP Connect scan. I'll not go through all of this documentation. You can read through this in your own time. We also have SU for UDP scans, so it won't scan UDP ports by default. You'll need to provide this flag, and bear in mind that UDP port scans can be particularly slow. We have a lot of other scan options here which I'm not too familiar with, and I won't be covering in this video. Again, you can go through this documentation here. If we go back to our terminal and run NMap, we can also get the shorthand for these here as well. The only other thing to mention is if we want to specify ports, we can specify ports in different ways. So we might want to specify ports and say -p-, and that will do all of the ports. Or we might want to manually say -p, and then we can say U. Say we want to do UDP port 53, and then we can do T, and say we want to do TCP port 80. So there are various ways that we can do this. We can also do this as a range, so we might want to do something like that. So in this case, I'm going to run the scan against TCP port 80 and UDP port 53. So we do need to provide the SU for UDP, and then we'll say SS for the TCP. And this will essentially, it's going to let us know which the vulnerable machines are, because I'm not running a HTTP server on any of the other machines or VMs. So let's try and run that and see what we get. You can see that comes back very quickly, and we've got our 5 hosts. We're able to see that we actually have the HTTP ports closed, is filtered, is open on this host, so the 0.5 is going to be of interest, and it's also open on the 0.6, so that's going to be of interest. It's closed on the other. So out of the 5 IP addresses that we've tested there, we've only found it to be open on 2 of the machines, as we would expect, and we know now to focus our further scans on IP 5 and 6. So I'm going to go back and actually update our IPs.txt. Let's take out the other hosts which aren't in scope, and let's go and have a look at OS and service version detection. So if we go back to the documentation here and we have OS detection and service and version detection. So service and version detection, first of all, you can see here that by default we're finding out what ports are open, but we can also use the NMap services database of 2,200 well-known services to find out what services are actually running and hopefully what version of those services as well. So let's try and run this again. We'll run the same scan, but we're going to do -sv, and we'll run it against the top 1,000 ports. You can see here we have some other options here to scan all ports and some additional version options. So let's try this first of all without OS detection. We'll just go back and do the same thing. I'm going to turn this off. We'll just do the default port scan, and we'll specify the service enumeration. So that took about 2 minutes to run, and now we can see that we've got some ports open here, and we can also see not just the service, so FTP, SSH, etc., but also the type of FTP server, and in this case a specific version of OpenSSH. We also have in this case an unrecognized service, so we might want to have a look at that for some more information. It might be a custom service or just something which isn't registered, and we have that for both hosts as well. In this case we can actually see here that it has come back service info. We can see here Linux, and we can see presumably with the other one, well, we have some mentions of Microsoft, so we can get an idea. Yeah, we have here the OS as well, so it did do the operating system detection as well. Let's go back and have a look. OS detection. So most fingerprints have a common representation as such, but we can provide this -O for OS detection. Let's go back and actually test that out. I'm going to test that out without the service enumeration just to see exactly what it comes back with. So that didn't take long to return, and this time, because we didn't run with the services option, we don't have the service versions listed here, but we have some additional information about the operating system. So previously we just had this CPE details, and now we have some suggested OS details as well for both systems. So you can see here that it's given an idea of the potential Linux version as well. Note that we can use the -A flag as well instead of doing this. So the -A flag will run an aggressive scan, which will essentially use a combination of different options. It'll use the OS detection, it'll use the service detection, and it'll run some default script scans as well, this -SC flag that we'll look at shortly. So that's another option if you want to run a quick scan and you kind of want to just potentially noisily grab as much information as you can. Then you can run it with the -A flag, as you can see has been used here in an example. Here's some more information about that. So it'll enable OS detection, version detection, script scanning, and traceroute. Next we're going to take a look at the NMap scripting engine, and I'm going to go straight to the reference guide because this is quite an important section. So the scripting engine is one of the most powerful and flexible features of NMap. It allows users to write and share simple scripts using the Lua programming language to automate a wide variety of networking tasks. You can use the -SC flag, and that will run a set of default scripts, but note that some of these could be intrusive, so you might want to run safe scripts or not intrusive scripts, and that will run a set of scripts from those categories, or you can load all scripts based on a certain keyword. So if you're testing the HTTP service, you might want to run HTTP-*, and that will run all of those HTTP related scripts. So let's go and test this out. Another thing to mention, script arguments. Some scripts will require arguments, and this is how you'll provide that using the key value notation. But let's go here as well, and you can also run, I don't know if this comes installed with NMap by default, but if you run NSE, you can grep for NMap scripts. So you can run NSE, for example, HTTP, and that will bring us all the different HTTP scripts. So that means if we run the script with HTTP-*, that's going to run all of these scripts that start with HTTP-. So we can test that out. Let's first of all, I'm going to go back and we'll run, let's do service enumeration here and OS enumeration, and we're going to run then the default scripts. So that's going to run all those default scripts, some of which might be intrusive. So that took about 2 or 3 minutes to run, and you can see that we get quite a lot more information back this time. We still have our services and the versions listed, but we also get some additional information. We have the SSL cert details here, we have a service which has been fingerprinted here, the string's been fingerprinted. We can see some files from the HTTP service here on the Ubuntu system, and the SMB service has been enumerated as well. If we go back to the NMap scripting engine documentation here, we can see that there are a lot of other categories. It's not just the safe and default and stuff like that. We also have external, fuzzer, intrusive, malware, safe, version, vuln. So we can go and have a look at the script categories section to get more information about how each of these work. Vuln is quite a good one. This will have a look for known CVEs. So let's actually just go back and test that out quickly. I'll run the same thing again. Basically, what we ran there as well, the SV and O and SC, we could just run -A, and that would do the same thing, the aggressive scan. But I'm going to do -SV again, -O, and this time let's do --script vuln. So the scan is finished. It did take nearly an hour to complete, so bear in mind this vuln script is quite slow. We were only doing that against 2 hosts as well, but it did come back with quite a bit of information. We have, you can see here the SMB vulns, these came back false, but we have a potential denial of service vulnerability here, and again another denial of service for the HTTP server. That's probably not too much use for us in a CTF or hack the box style machine, but if we scroll up here we can see we've got some CSRF vulnerability. We have the MySQL, which didn't manage to execute the script, so you can debug that. That might be because we needed to provide some additional parameters, I'm not too sure. And again, scroll through this, quite a lot of stuff here. It's done some brute forcing of the web directories, found the admin folders, and a lot of CVEs here to go and investigate. I'm not too sure how many of these would be false positives or not, and how many will be useful depending on what you're trying to achieve. You might have some things which are local vulnerabilities only, so you need to first get a foothold or get user level access before you can then escalate the privileges. But this gives us a good start in place, so whenever we're going through the Metasploitable 3 machine, we can go and investigate some of these CVs a little bit more. The slow speed of that scan is a perfect segue to the next section, which is timing and performance. So this isn't something I have too much experience with. If you go and have a look here, you can find a lot of different options which you can specify to either increase the speed of your scan or to try and slow the scan down so as to avoid detection. I haven't really played around with any of these options. The only thing that I have used is the -T flag here, which is a timing template. So essentially it will use a different combination of these finer grained controls above to provide a timing template. So you can see here we have paranoid, sneaky, polite, normal, aggressive, and insane. So some of those will be good for evading firewalls and intrusion detection systems, and then in other cases, maybe depending on the bandwidth that you have available to you or how fast you need the scan to be done, you can basically pick these different options with the -t flag. So they're the only ones I have any experience with. If you want to go and find out some more information about them, you can have a look at that in the documentation. So we saw there that the timing templates can help evade intrusion detection systems, but there are some more powerful features in NMap to do that as well. One of them is to fragment packets with the -f option, and I did a video on frag router not too long ago, so this would be the same sort of idea here, that we fragment packets in order to bypass the intrusion detection system. Any kind of packet rules which are set up might be bypassed using this. We also have the -d, capital D, for decoy, which will cloak a scan with decoys. So this is a pretty cool feature. You can specify how many decoys you want, and there'll be unique IP addresses, so you might have 10 or 100 IP addresses, and essentially whenever you run the NMap scan against the server, it'll run from all of the IP addresses at the same time, and the server won't know which is the real IP address and which are decoys. You have to be careful to make sure that the hosts are up, otherwise, or at least most of the hosts are up, otherwise you could cause a SYN flood against the target in doing that. Similarly, you can spoof the source IP address, but this isn't particularly useful because you won't actually get the results back. The receiving packets will go to the spoofed source address. I guess this could be used in order to try and pin an attack on somebody. I'm not really too sure. Here it gives an example saying, imagine a company being repeatedly port scanned by a competitor. So I guess you could imagine a scenario where after a successful intrusion, the attacker might do a lot of scans against whatever service was exploited from a spoofed IP address to try and pin the blame on somebody else, possibly somebody in a different country, which is well known for cyber attacks. There's other options here. You can spoof the source port, you can spoof the MAC address, you can send data, binary data, hex data, etc. in the packets. I haven't played around with a lot of these options because in the kind of scenarios that I've been using these in, so hack the box and vulnerable machines and OSCP and things like that, it wasn't really necessary. In some cases the timing template helps, but these weren't required. The next thing we want to have a look at is output. So we can export the NMap scans into different formats, as we can see here. We can export normal, XML, script kiddie and greppable format, or we can use -OA and give the base name, and this will give us all of the 3 formats at once. So we'll go and test that out in a second. We can also increase the verbosity level, so this would be useful, for example, in the scenario where we were running the vuln scripts against the 2 hosts and it took nearly an hour to complete. If that was an attack defense CTF and you had to wait nearly an hour to find out which ports were open, it wouldn't be much use. But if you have the verbosity level set a little bit higher, you can see the ports as they're discovered and you'll be able to kind of work as you go in. Let's test this out anyway. I'm going to run nmap. We'll do sudo nmap dash, we'll do -il and pass in the IPs list, and then -sv for service enumeration, -o for the OS detection, and then we'll do OA to output in all formats, and we can give it a name then. So I'm just I'll call it nmap scan, and that will run through. Note that you can also import some of these exported scan results into different tools, for example Metasploit. So Metasploit allows you to import the XML results, and if you imagine you have a network of hundreds of machines and you run the NMap scan, you import it into Metasploit, and then you're able to just list all the different host IPs, all the host names, all the ports and services that are available, and you can quite easily then just search for all the hosts which have, for example, SSH, OpenSSH 6.6 running, etc. So I'll not go into too much detail on that. I'll save that for the Metasploit episode when we go and do some actual exploitation. But that's completed anyway, so let's see what we have now. We can see we've got these NMap scans, so we can take a look at them as NMap, the GN map, which I guess is the greppable format. We have the NMap, which will be the normal format, and we have our XML. In fact, we'll save the XML, we'll have a look at that in a better editor. Did we have the script kiddie one as well? No, okay, we didn't have the script kiddie one. So let me just open up the NMap scan XML. And this gives us a nice structured output that we can then put into a lot of different tools. The script kiddie is basically, I guess, just kind of a joke option. Let me go and have a look at the full reference here. I'm going to have a look at output. So there's a variety of other options here which I haven't covered in detail, but you can see that one of them is the script kiddie output, which will basically just give you a camel case and replace some of the letters with numbers, etc. So that basically concludes the NMap introduction. A couple of things I'll just mention in closing. If you're interested in using a graphical user interface for NMap, you can use ZenMap, which I don't have installed at the moment on Parrot, so I won't demonstrate it here. But if you have Kali, it'll probably be installed already, and it'll give you all the same stuff that you have with NMap, but with a graphical interface if that's what you're into. Another thing to mention, NMap can be quite slow at discovering open ports, so you can look at Masscan, which will scan the entire internet in under 5 minutes, transmitting 10 million packets per second from a single machine. So I use this quite a lot during my OSCP, where I would initially scan all 65,000 TCP and UDP ports on each host with Masscan because it's quite quick, and then based on which ports were open, I would then do a more in-depth NMap scan to identify the services. And to do that, I put together a basic script. You can see here it's on my GitHub, and it'll basically just take in the results from Masscan and produce an output which can then be fed into NMap to do a more detailed scan. I must say that I put this together a good few years ago now, and it's probably not your best option because you have things like RustScan which are available, which as far as I can tell will kind of combine Masscan and NMap together. So you can see here it's fast, smart and effective, and it tells us that we can find ports quickly, so 3 seconds at its fastest to find all 65k ports. I wonder whether that includes TCP and UDP, I'm not too sure. I'd be surprised if that's UDP as well. But it also says it has adaptive learning as well to improve over time, and it pipes ports directly into NMap. So basically what I was just talking about with the script that I put together, but I'm sure this has been done a lot more professionally. So maybe I'll do a separate video on this at some point once I've had a chance to explore all of the features. But I hope you've enjoyed this video anyway. If you have any questions or comments, please leave them down below. Thanks.